Okay, in this video, we're going to be using regression formulas in Desmos. So I'm going to show the process for how you create the table, make sure your columns are set to X1 and Y1, how you load the data, and then how you type in the formula. I'm only going to be typing in the linear equation and the quadratic equation so that you can see how you handle the, like here in the quadratic, you have AX squared, where it says AX1 squared. We want to make sure we know how to type that in. Okay, so actually, I'm just going to use the quadratic data here just so it makes it easier. Everything else is basically self-explanatory once you get it in there. So, all right, so the first thing we have to do is create the table. So we're going to click on the plus up at the top left where it says Add Item. We're going to click on Table. We're going to make sure that the columns say X1, Y1. If it says X2, Y2, then when you're loading or creating your formulas, you have to make sure you say that you refer to those column names. I just find it easier to always start fresh, clear everything out, and then when I hit add new item, that the columns are going to say X1, Y1 every time. All right, so now we're going to load the data. Go ahead and pull this over so I can see the numbers. We have 7.000 and 104, and then we have 8.00 and 122. Now, you could, at this point, go ahead and create the function. I'm going to go ahead and do that so you can observe what happens to the values. So you have these target numbers in here that we're expecting to see because this has already been done before. But if we only use two of the values, this is what you end up finding out. So we're going to say y1 squiggle, which is right next to the 1 on your keyboard. You got to hold shift and then push the button to the left of the number 1 on your keyboard. And then it's AX1. You have to do AX1 first and then do shift 6. Put your square, move to the right, do plus BX1 plus C. Okay, and now what you're going to find out is as you are typing this out, these parameters A, B, and C are going to change for your function. So right now, A is 0.392857, B is 12.1071, where C is 0. And that's because we only have two data points and we're trying to do the regression formula for quadratic. So I have to actually include all of the data points that are in my table set. So if I do 10.25, 167, you're going to see now I'm starting to get different ABC values, but I'm still not exactly at the same location. You'll also notice that the R squared is 1. That's because you need more than 3 data points to really get the um, coefficient of determination on this one here. All right, so we'll go 13.50, 159. Now you see that the R squared value dropped from 1. Now it's 0.9817. That is extremely high for an R squared value, meaning that we can use this current formula to predict if this is all the data points that we actually had. Okay, as I add the last data point, you're going to find that the R squared drops to 0.9677. A is now what it's supposed to be, and so is B and C. Okay, so this is how we enter the data, how we type the function, or how we type the formula in for the regression for quadratic. And if I wanted it to be a function, then I'm going to create a function, f of x, or whatever I want to call it. I can be g of x, I can be h of x, I can be f of t if I wanted to. It doesn't really matter as long as I use that variable in the formula. So let me go ahead and do f of t. So if I do f of t, then I'm going to call the function a, which is negative 2.5969. We're going to do some rounding, so negative 2.60 t squared. Instead of x, I'm putting t since my function takes an input of t. And then I'm adding 62.67 t, and then I'm subtracting 208.76. Okay, so now here we have our function. And if I wanted to call the function, say I wanted to go, say this was a time interval for seconds, and so let's see what it would be if it was 20 seconds. We would have 4.64. So you can see the value ended up dropping pretty significant in this case here. Just make sure you have all the values typed correctly. And in this case, I do. And that's how you use regression formulas in Desmos.